Building construction for the fire service, week 5, problem 3. This is a problem that you saw before, and again, this week's materials are all review from previous units. I'm going to solve this in a slightly different way than you solved it previously. Let's start out with the sum of the forces in the x direction. Sum of the forces in the x direction equals 0. There are no left or right forces. Sum of the forces in the y direction equals the weight of the person, which is, again, negative 160 because it's a downward force, plus the weight of the board. And the weight of the board is 140 pounds, and we can consider it to act at the center of the board. So there's this point, and it's 6 feet from either end, because the entire length of the board is 12 feet, and it is 140, so negative 140. Now, there's a force at B, and there's a force at A acting on this board. So the sum of the forces in the y direction equals negative 140 plus negative 160 plus A, the force at A, plus the force at B. And maybe I should denote those with an F. Forces at A and forces at B. Now, that doesn't get you anywhere. What you have to do is you have to use the sum of the moments. And this is where we're going to change the approach to this problem this time compared to the way that you solved it last time. For this approach, I'm going to use the sum of the moments about point B. So we're just simply moving the pivot point, and that's allowable under statics principles because you end up with the same result. So the sum of the moments about point B. Well, where is the center of the board relative to point B? It's 2 more feet because it's 4 feet from the end of the board to point B, and then it's 6 feet to the center of the board's effective weight. So again, this is a positive 2 feet times a weight, negative 140, because it's acting in the downward direction. And you can see that this is going to produce a negative moment, and that's what we want because this board has a tendency to rotate clockwise about point B. Plus the moment, how far is the swimmer from point B? 8 feet times a weight of negative 160 plus, and here's the thing, point A here now is going to create a moment opposite B. So if you think about both of the moments created by the weights, they are negative moments. They're making the board want to roll in this direction. The column at point A has got to create a moment in the opposite direction, which means that column A is going to be in tension. And that you'll recall from the previous time you solved this, that was the case. So you can just kind of intuitively realize that column A is going to be in tension, and because column A is pulling down on the board, the column B is going to be in compression, and the upward thrust of column B will be greater than the sum of these weights because it's these weights plus the reaction provided by column A. So it's going to be column A, which is 4 feet to the left of the fulcrum. So this now becomes a negative distance, negative 4 feet, times the force developed at A. And what do all of those have to add to? They all have to add to 0. Now, let's crunch some numbers. Negative 140 times 2 is negative 280. Negative 160 times 8. I can't do that one in my head, so we will pop up the calculator. Is negative 1280. Plus negative 4, force developed in A equals 0. So what do we want to do? Well, we want to get force divided by, or the force in A on the other side. So we're going to basically add 4 times the force of A to both sides, and we'll sum these up while we're at it. So 200 plus 1280 is 1480 plus 80 more is negative 1560 equals, and now I'm going to add 4 times the force at A to both sides. That gives me 4 times the force of A. Negative 1560 divided by 4 gives me the force at A. And you'll notice that it's going to be a negative number, which is a good thing because that reflects the nature of column A as being in tension. So 1560 negative divided by 4 is negative 390 pounds. So what does that mean? That means that column A is pulling down with 390 pounds. Now, if you think about the force that column B must be pushing up with, it has to be equal to and opposite these 3 forces, since these are all in the downward direction. So negative 140 and negative 160, those add to 300, negative 300 I should say, and negative 390, so negative 390 plus negative 300, this has to be 690 pounds upward. It's under 690 pounds of compression. And you see that agrees with our answer key. Now, if you look back to how you solved this in the chapter where this problem appeared, you'll recall that we had actually set the fulcrum at point A and gotten the same series of answers. So I won't belabor the point here and recalculate this with the fulcrum in a different spot. But what is worth noting is that you might look at these 2 columns and think that they're both under compression or that they're equally stressed or any of those things. And none of that is guaranteed. And you can see that here, that this column B is much more highly stressed than column A. Being able to do that type of analysis can really help you on the fire ground, because you may be able to make some good kind of engineering estimates as to which components of the building are most stressed and which are most likely to fail imminently.